Bermuda is a coral atoll lying atop a gigantic drowned mountain about 800 miles off the coast of North Carolina. It marked a turning point on the great trade route coming from the Caribbean through the Florida Straits and was a signpost pointing toward Europe for ships to pass the islands, ran aground in storms and fog. The western reefs are a vast graveyard of such sunken ships, numbering in the hundreds. We are here with Explorers Research Corporation to find some of these historic wrecks using the latest underwater electronic detectors. Since the 1840s, Gibbs Hill Lighthouse has stood on a prominent hill on the western side of the islands, warning ships of the dangers of the Bermuda reefs. Nearby on Mangrove Bay stands the home of the well-known Bermudian diver and salvage expert, Teddy Tucker. Mr. Tucker will work with the expedition in our search for historic wreck sites. George R. Wallace, president of the Explorers Research Corporation, goes over some of the documents pertaining to the sites of the Virginia Merchant, which sank in 1660, and the Warwick, which went down in 1619, two of our most important targets for the electronic search. The documents are contained in a volume edited by an early governor of Bermuda. Mitzi, the expedition mascot, is a rare strain of seagoing schnauzer. We will use Tucker's salvage vessel, the Brigadier, in our search and salvage operations. The boat, some 45 feet long, is fully equipped to perform search missions and can support up to 4 working divers at a time. The changing colors of the water indicate we are on the reef flats. The depth of the water is indicated by the fathometer. Depths of water on the reef flats vary from a foot to 30 feet. The deep holes are indicated by light sand bottoms, while the shallow coral heads appear as dark spots. Our first target will be the site of the Virginia Merchant. Flying the flag of the Explorers Club, the Brigadier runs up and down the south coast where the Virginia Merchant was wrecked in 1660 with a loss of almost 200 lives. We are looking for new deposits of historic treasures which are scattered about in a wide area in a sand bottom between coral reefs. The ship was en route to Virginia with badly needed supplies and emigrants when she met her end. Our electronics engineer adjusts the magnetometer as we prepare to sweep the area. The sensors are launched and ride back on the cables, which are carried on outriggers to keep the sensors apart. The heads will ride about 6 feet underwater and about 20 feet apart. Any trace of iron in the ocean bottom will be detected by the instrument. The boat will run on a grid pattern in an effort to probe every square foot of ocean bottom in the target area. The sensors ride smoothly through the water, recording the fine lines of the Earth's magnetic field. Any interruption of this field by iron in the ocean bottom will be detected on recorded topside. The electronic signal from the sensors is amplified and converted to mechanical motion by the readout instrument. Any radical movement of the needle indicates that the instrument is running over iron in the ocean bottom. As the sensors crisscross the ocean bottom in the target area, they pick up abnormalities in the magnetic field. The needle goes wild and indicates masses of iron in a sand hole between the coral heads. We believe we have found remains of the Virginia Merchant, but must dive on the spot and dig exploratory holes to locate the iron deposits and confirm our discovery. As we anchor over the site, the divers prepare to go down. The standard gear for recovery operations is a U.S. Navy light diving mask supplied by air hose from a pump on the boat. Lead belts keep the divers from floating up, and flippers enable them to move freely underwater. This faithful old compressor has kept divers alive for the past 15 years. One of the great iron guns of the ship is found, and George Wallace joins Mendel Peterson in examining it for marks which might identify it with the Virginia Merchant. A heavy surge is running on the spot. Sea plants wave about in the coral. The boat rocks sharply, and one must move with care, both underwater and on the boat. It is believed that the main deposit of iron picked up by the magnetometer is in this sand hole surrounded by sharp coral heads. To locate the exact spot in which to dig, Tucker carries a spar with the sensors lashed to them. The signal is read on the instrument on the boat, and Tucker is given a signal down his air hose to mark the spot where iron is indicated. Holding one of the sensors as a spot detector, Tucker confirms the exact location of iron deposits under the sand, and we are now ready to dig a test hole. The digging will be done with the airlift which is thrown overboard to the divers waiting below. The airlift is a large open tube up which air is pumped. As the air rushes up the tube toward the surface, a great sucking action takes place. This acts as a sort of an underwater vacuum cleaner, and tons of sand can be moved with the device in an hour. A diver always watches the fallout from the airlift to catch objects which might accidentally enter the tube. On the surface, a mass of bubbles shows the exact location of the airlift working below. The first object, a fine ivory comb in perfect condition, comes up, held carefully by Alan Albright. Round lead scale weights are found and brought to the surface. The comb and the weights are the right period for the Virginia Merchant. Clay pipes and a razor hone join the growing pile of artifacts, which now confirm the site to be that of the Virginia Merchant. These clay pipes were the usual means of smoking tobacco in the 17th century. 3 varieties of pipes were found. The sand hole begins to produce heavy iron objects. This is the iron which was detected by the magnetometer. A bucket of coral-encrusted cannonballs comes up. This iron hook was used to secure one of the big cannon of the ship. Some 25 pounds of swan and buckshot, destined for the Virginia colonies. An encrusted broad axe, which was destined to cut timber in Virginia. This conglomerate contains ivory-handled knives and forks. The ends of the ivory handles protrude from the mass. Iron parts have corroded away. Peterson comes up for a breather. The sharks of Bermuda are very punctual. Most leave the shallow water at 10 a.m. and return about 5 p.m. The small sharks usually appear first, and mother and father are not far behind. When we see them, we know it is time to get out of the water. Shark is a delicacy in Bermuda, and catching them is great sport. The shark is killed with a hammer blow on the nose, the center of their nervous system. Testing a large magnetometer underwater vehicle was one of the lesser projects of the expedition. This sensing head was designed to run in deep water and performed well. Divers check the stability of the new vehicle. A big sensing head with bat wings looks very much like a new species of manta ray as it slides through the water. The sensing head slashes by at a depth of 12 to 15 feet. The large lead weight on the bottom acts as a keel. The readout instrument for the big magnetometer stands to the left. Checking the attitude and performance of the new vehicle underwater, our electronics engineer, William Byrd, photographs the instrument as it runs through the water. The human eye is still one of the best detectors, even in this age of electronic miracles. Tucker swims over a site where a young fisherman, William McCallan, found an iron gun. The cannon lies in a sand hole in 25 feet of water, where it fell from a ship in a storm. Inspection of the gun proves it to be of the late 16th or early 17th centuries, and we decide to raise it for preservation in the Smithsonian collections. Tucker rigs a line to the gun at the point of balance for lifting to the salvage vessel. Over a ton of cannon must be carefully handled in rough water. A rope is attached to steady the cannon to prevent injury to the salvage boat. One area of the survey was off the southeastern coast of the islands. The readout instrument goes berserk. A large mass of iron is below us in 80 feet of water. The divers find the almost intact hull of a large steel ship. Tucker recognizes it as a freighter which went down during World War II. Graphic evidence of the dangers of Bermuda reefs, even in the age of modern navigation. The big iron boilers of the ship stand on end where they have tumbled. Alan Albright swims through the main engine and records a jumble of connecting rods. The bow of the ship rests on a coral head and the keel forming an underwater bridge. Nearby, the wreck, a natural underwater tunnel in the coral, lures explorers. Merchant ships have been wrecking on Bermuda Reef since the beginnings of trade in America. The Caesar was loaded in England with a cargo for Baltimore, but struck the reefs and sank in 1818. The grave of the Caesar is marked by a reef of grindstones and brick, which formed the bulk of her cargo. Grindstones of all sizes are there, small ones of a foot in diameter to giants 5 feet across. The yellow English brick in the cargo may have been destined for iron furnaces in America. The airbag is a standard tool for lifting moderate-sized objects to the surface. On the side of a French warship, the airlift foams busily by the brigadier. The French frigate Lerminy, 60 guns, sank on a reef late in 1838. The ship was an entire loss, but the crew was saved. This site is one of the largest and most productive in Bermuda waters. Iron guns weighing up to 4 tons mark the site of the ship. The vessel was beautifully built, being fastened with large copper bolts. Fragments of the hull lie about over the site. Probing in the wreckage uncovers an interesting collection of artifacts. An encrusted nail from the hull planking. A pottery jug which held vinegar or wine in the wardroom pantry. A coil of rope from the boatswain's stores is uncovered. It still retains the shape, but is completely rotten and breaks as it is lifted. A large hammer from the chest of the ship's carpenter with handle intact, but weakened. The wardroom was well supplied with wines and liquors. Fragments of champagne bottles abound on the site, and a few are found intact, having been protected by a sand cover. Brandy, wine, and whiskey bottles are also found in some quantity. The number of bottles found on the site led one wag to conclude that this might be evidence of the cause of the wreck. Actually, the officer commanding the ship was cleared in a court-martial held in France the next year. The meat supplies were carried salted in barrels. This is part of a top for one. This brass door frame once held plate glass and formed the front of a surgeon's instrument case. Usually it is best to bring up very fragile objects in the hand. This is especially true of unbroken bottles. When rough weather keeps us from the outside reefs, bottle hunting trips are taken around the old Navy Yard. The waters around Bermuda abound in old bottles. It is a collector's paradise. Some in this group date as early as 1830 to 40. The weather is cleared outside and we go to visit a clipper ship. The clipper ship North Carolina lies in 30 feet of water on the reef flats, easily visible from the air. This beautiful, swift vessel was wrecked in 1882. The fine lines of her bow are still visible. The great wooden bowsprit of the ship jutted from these iron rings at the top of her stem. Schools of fish make their home in the shattered hull. In 1619, the ship Warwick was wrecked in a violent storm on the south shore of Castle Harbor. The exact site has been forgotten through the centuries, and we are determined to sniff it out with our modern proton magnetometer. The Brigadier runs a tight grid pattern over the suspected area. Here the probing with a magnetometer is essential. The deep silt in the harbor covers everything, and there is no possibility of seeing the remains in the water. The site is believed to lie at this spot, near a rocky cliff. A strong indication of iron is found and rechecked. We must now dive to identify the iron deposit. Mitzi the mascot thinks she can smell the wreck. The divers will be working in water where the visibility is only a foot or two under the best conditions, and less when the airlift is pumping up the silt bottom. In the milky gloom of the harbor, the remains of a ship are found. Ballast stones and an encrusted iron hull bolt are located. Finally, after several days of pumping, the bottom timbers of the ship's hull are uncovered. The ship lies on her side and the timber is preserved from the keel to one gunwale. Here we have the most extensive remains of ship timber of this period ever found in Bermuda. For 2 weeks, the airlift worked on the site. The murky water was a hindrance but did not slow down the operation. Evidence on the identity of the vessel piles up. At one point, Tucker pumped up flour from collapsed barrels in the ship's hold. The Warwick had a large cargo of flour aboard. A small gourd bottle is found and carefully wrapped in saran wrap to prevent it from drying out. The Smithsonian Institution Laboratory. The work underwater comes to an end and the collections recovered must be cleaned and packed for shipment to the Smithsonian for preservation and study. A piece of iron bar going to the Virginia in the Virginia Merchant is cleaned and examined before packing. Wood which is not treated cracks and shrinks on drying. This bar shot from the Virginia Merchant was a deadly weapon when fired against an enemy. It could rip sails, destroy lines, and seriously injure spars. Fired across the deck, it could kill or maim. Another type of bar shot from the Virginia Merchant. This one consists of 2 iron balls cast on a wrought iron bar. task of packing begins. The rum barrel is the best container in which to ship valuable historical objects. The barrels are loaded through a hole cut in the head. When the hole is open, we are eager to see if rum is left in the barrel. Objects are packed in layers of sawdust or shavings, protecting them from shock when the barrels are handled in shipping. Each container is numbered in the contents catalog. The packing completed, we must take one last look at the site of the Warwick. The evidence conclusively proves we have found the ship after 3.5 centuries. In the future, we will return to the site of the Warwick and recover and carefully measure her remains. This halt may teach us much about English ship construction in the early 17th century. Our expedition has been an unqualified success. We have discovered 2 significant 17th century sites, have tested new electronic gear, and have assembled important collections of exactly dated objects, which will teach us much of life at sea in the age of sail.